we will continue again with calculating normal probabilities. Probability x is less than 45, is greater than 45 and less than 60. We apply that to the formula, and we've got probability 45 minus 50 over 10. 50 is the mean, 10 is standard deviation. This is less than x minus mu over sigma, which is z, is less than 60, which is x minus 50, which is the mean over 10, which is standard deviation. This works out to be finding the probability that z is greater than minus 1.5 and less than 1. Now we look at the tables to get the actual result. Okay, we've converted probability x is greater than 45 and less than 60 for normal distribution with mean equals 50 and standard deviation 10 to the probability z is greater than minus 0.5 and less than 1. That is the standard normal distribution with the mean equals 0 and the standard deviation equals 1. So where do we go from here? Well, this is using the older texts, though, but the method is still the same. The probability z is less than 5, greater than minus 0.5, and less than 1 looks like this. In this type of problems, it's always best to draw a diagram. The probability is the area under the curve. So we draw a curve, and we add up the two sections. We see there are two sections here. And between 0 and 1, and between 0 and minus 0.5. The approach here is a little different using the older text, but in terms of reading the probabilities from the tables. But we will go through nonetheless. Calculating normal probabilities using table 3. Using table 3, appendix B, to look up the probability that x z is greater than 0 and less than z. Z lies between 0 and z here, as shown. This is the area. We want to find the probability z lies between 0 and 1. First part of the problem. So we break up z greater than minus 0.5 and less than 1 into z less than 0 and greater than minus 1.5 and z less than 1 and greater than 0. In red color-coded as shown, you want to find the probability z is less than 1, that is between 1 and 0. You want to find this area. The distribution is symmetric around 0, so multiplying so by minus 1 and arranging the terms, we have blah blah blah. This is equal to that. In other words, what they're saying here is that because of how the tables are constructed, you can't read negative values. So you read the positive value, that is the probability that z is less than 0.5 on the other side. Read that value, and by symmetry, it's going to be the same as the area between 0 and minus 0.5. Having obtained these two values from the tables, they're added to give you the results. How to use table 3. This is really on how to really use the tables, and you must take special attention in how to read the tables. This table gives probability values. Probability z is less than little z and greater than 0. That's between 0 and actual value. So the probability that z lies between 0 and 0.5 is given by 0.1915. The probability z lies between 0 and 1 is 0.3413. So the probability z is greater than 0.5 minus 0.5 and 1 is obtained, as we said before, by adding these two probabilities. 0.1915, 0.3413 gives it 0.5328, and the result is obtained. Where is the no, the time required to build a computer is normally distributed with a mean of 50 minutes and a standard deviation of 10 minutes. What's the probability that the computer is assembled in between the time 45 and 60 minutes? We just calculated that to be probability that x is greater than 45 and less than 60 is equal to probability that z is greater than minus 0.5 and less than 1. It works out to be 0.5328. Just over half the time, 53% or so, a computer will have an assembly time between 45 minutes and an hour. That's the answer. Now, this further examples here are examples in reading the tables, various areas in the table. For instance, what is the probability z is greater than 1.6? Z is greater than 1.6. Remember that your tables only have cumulative values. Probability z is less than k. In the earlier text, probability is less than k and greater than 0. So it's between 0 and k. Here, the probability that z is greater than 1.6 really refers to this area. But this isn't the area we're interested in. We are interested in this area, but we can't read this area directly. We can find the probability that z is less than 1.6 and greater than 0, between 0 and 1.6, which is how the table reads. This area is 0.4452, read from the tables. By symmetry, this area to the right of the 0, the whole area is 0.5. So this little area must be obtained by subtracting 0.4452 from 0.5. That is, subtract this white area from the total area to the right of the 0, and that gives you 0.0548. 0.05 minus 0.445 to 0.0548. So the probability z is greater than 1.6 is 0.0548. You want to find the probability that z is less than minus 2.23. If you're using in your text, that is just read directly. That is just read directly from the tables. This example refers to an earlier text, and this is obtained as follows. You want to find the probability z is greater than 2.23, because this area is going to be the same as this area by symmetry. Again, we can't find the probability that z is greater than 2.23 directly. That is not written in the table. What we know is the probability that z is less than 2.23 and greater than 0. That is this area here. This can be read from the table. The probability z is less than 2.23. And this gives probability z is less than 2.23 is this is z is less than 2.23 this works out to be 0.5 minus the probability z is less than 2.23, which you would read 2.23, which is read from the table, and the result is 0.0129. That is, you'd read 2.23 in the row and column accordingly to give you the value for this area here is shown. You subtract this from 0.5. Remember, the whole of the area to the right is 0.5, and that will give you the resulting answer, which is 0.0129. As I said, if you're using an earlier version, newer version with the text, you'd read this value directly. Since the table has negative values, probability is less than minus 2.23 is just read directly. Now, using the table again, table 3 again, what's the probability z is less than 1.52? So we're talking about this whole area here. Well, you know that this area to the left of 0 is 0.5. That's the probability z is less than 0.5. So you need to find the probability z is between 0 and 1.52. That is, they want to find the probability the z is less than 1.52 and greater than 0. This is read directly from the table. The probability z is less than 1.52. Probability z is less than 1.52. That is the area here I'm touching. That is 0.4357 added to this area, which is 0.5, the area totally to the left of the 0, the other half of the distribution. This area is 0.5. Remember, the whole area is 0.1. So you add in 0.4357 to 0.5 to give you the total shaded area in red, which is 0.9357. This is another one. It's a bit more involved. I said if you're using the newer versions of the table, you read the probability z is less than 0.9 to give you the whole area here. The probability z is less than 1.9, which is the whole area from this. You subtract the areas, and that will give you this shaded area. We're going to go according to this example in the older text. The probability z is greater than 0.9 and less than 1.9, you will draw the diagram and indicate the area. And to start, the probability z is less than 0.9 and greater than 0 is this area here, which is read from the table. The probability that z lies between 1.9 and 0.9 this will be obtained by finding the probability that the z is less than 1.9 and greater than 0. That is the area from 1.9 here to 0. Find that area. That read from the tables will give you 0.4713. 0.4713, and you want to find the probability z is less than 0.9 and greater than 0. That is, you want to find this area here. This is 0.3159. You take this area here from the area between 0 and 1.9, and that gives you 0.1554. That's your exercise in reading the tables. There's a quick example here. The return on an investment is normally distributed with a mean of 10% and standard deviation of 5%. What is the probability of losing money? Probability of losing money means the probability that your return becomes negative. That is, we want to determine the probability x is less than 0. I mean, what's the probability x is negative? X becomes negative. The probability x is less than 0 is the probability that x minus mu over sigma, which is z, is less than x minus mu over sigma. X is 0, mu is 10, and sigma is 5. You want to find the probability z is less than minus 0.2. And this is done reading the table as follows, as we've done before. That gives you 0.5 minus 0.4772. And that gives you 0.0228.